The broadcast is now starting. All attendees are in listen-only mode.
Welcome to today's webinar, A New Media for LON Networks. Please note this webinar is being recorded and will be made available on the LonMark website for future reference. Following the presentation, there will be some time to address questions related to the webinar content. If you have a question for a speaker, please use the question box on the right-hand side of your screen. Questions will be read and addressed by our speakers. At this time, I'd like to turn it over to Ron Bernstein, CEO and Executive Director of LonMark International, to give some opening remarks and to introduce today's speakers. Ron?
Thank you, Shannon. Welcome, everyone. We have an interesting webinar today on a new technology that's been embraced by LonMark. Some folks might know about Powerline Carrier as a media supported by LonWorks for many years. However, the new technology is much faster, much more up-to-date, and has some very advanced applications. So we're very excited to have our three speakers today. Let me introduce them. We have Ernst Eder, who's our LonMark Technical Director, and he's going to talk a little bit about the standardization process and kind of where we are with HD-PLC and a few points from the LonMark perspective on standards development. Then we have Michael Navid from MegaChips, and they're a LonMark member who's going to focus on the core technology of HD-PLC and how it works and its performance and features and functionality, and get some getting started information for those interested in that. And then Matthias Lürkens from Gesitech is going to focus on implementation, use cases, some examples of applications, a starter kit, and take some questions on applications. So without further ado, let me introduce Ernst Eder. Ernst, if you would take it away, please.
Thanks, Ron. As Ron mentioned in his intro, I will give you some background information, how LonMark members created standards and how LMI supported that work. I will give you some background information, some historical information here. In 2017, we had some LMI members that brought in the idea of adding two new communication standards. The first one was HD-PLC, and the other one is a new wireless channel. There will be another webinar which covers the wireless channel. We will hear later in the presentation about when this takes place. So we will focus mainly on the HD-PLC channel. But for me, since this was in parallel, I mentioned both of them. As you know, we already have an Powerline channel, so why have a second one? And this is an easy answer. It has a much higher bandwidth. Therefore, different application or other applications can be managed with it, like streaming videos. But this we will see later with Michael's presentation. For doing this work, LonMark established a committee, the so-called LCSC, LonMark Channel Standardization Committee. In this committee, we had 27 meetings, and in these meetings, we created a document, a standard draft, and submitted that to national standardization bodies. Here I also want to mention the participating members. There were more, but this the one which were involved in creating the standards. I would say we had two consorts here. The one was MegaChips with Gesitech, where Gesitech brought in the LON special knowledge. And the other one was Panasonic, Vossloh Schwabe, and with the also LON specialist, WHO engineers. The last one is Wirepass, and these are a company who does wireless communication, which they are specialized there. They are split off from Nokia, so they are very good in wireless communication. So in these meetings, we created documents which defined and documented all information that is necessary to integrate this new physical layers in our LonMark environment. And with doing that, we then submitted both of them to the national standardization committees, one in Europe. So this was then CEN TC247 Working Group 4, where our European standards family, the 14908 is, and here it will be then 14908-8 and -9. So we already have a new work item established, and the drafts will go then out to the national standards bodies here in Europe. And the other one is CTA R7 Working Group 13, and here is the US standard family, the 709, and here it will be then 709.8 and .9. Here the review is done, and it's, I think, already voted, so we are very confident that we will have very soon published and released US standard. In Europe, this will take, I would say, longer, say it that way. The next step, of course, for us then is to bring this national standards on the international level, which is ISO IEC. And here our standards family, this 14908, is in GTC1 SC6. So that's the plan. That's the plan here. So last slides was about national and international standards. And now I will go back to LonMark and what is LonMark providing here. We will incorporate this two new standards in our LonMark standards. And here it will go mainly in the LonMark layer 1 to 6 interoperability guidelines and in the standard transceiver files. Information about all these standards can be found under the following web link. So I will just go for 1 and 2 here as a short explanation. The LonMark lower layer guidelines or layer 1 to 6 interoperability guidelines have all our channel or our transceiver definitions in it. Like FTT10, like the power line, like IP852. And we also now included, the work is already done in some work groups, we also include now the 2 new channels. So all the information that is necessary for certifying device and of course developing devices and then certifying devices. It's network cabling, schematics are in there, coupler circuits. I'm not sure if you ever read it, but this information is available there. And as also already mentioned, all the information which goes in there is based on this national international standards. The second information is then this LonMark standard transceiver files. This is an XML file which is used by development tools and which is used by the integration tools. It has all this necessary information about this standard transceiver IDs. It has information about channel parameters like timing, clock rate, bit rate. This can also be found on our website under the following link. So from the LonMark side, I think we are ready, and this is also for our member. This is also valid for our member companies who have helped to develop these standards. We have the guidelines ready. The member companies have the development tools and the hardware ready. So we will see later on regarding the hardware and the development tools. Of course, you can also use development tools which are already out there, like Node Builder. So everything, I think, is ready. And last but not least, LonMark certification tool is also ready to test and certify the devices. Here I've summarized what LonMark standards are for and what the advantages are. Of course, for the end users, they are asking for standardized hardware. You know, in specs, standards are written in, so this is a necessary thing to have. Second, and we also see this here today, second source supplier are available. And then the other thing is for system integrator. And here I think I want to mention one important thing is all this can be used and integrated with standard tools which are out there and which are used in the past. So like just the tools we already have. And other thing is, of course, between the new channels and the old channels, there is a seamless communication. There are no gateways needed. It's just routers which transform between different channels like HD-PLC and an FTT channel or an IP channel. So this is, I think, a very important part for system integrators. That they can use all those things which they already used in the past. So here I come to my last slide, and this is about the whole standards family in international, Europe, and America. As in red, the standards will be standardized or are in process to get into the standardization committees. But I mentioned this before, for ANSI, we are very close to get it. Okay, that's my part. We will have later on the Q&A section. So I will now turn it over to Michael. Michael, it's your turn.
Thanks, Ernst. Hello, everyone, and welcome to our webinar today. Over the last few years, we've seen a dramatic increase in the bandwidth demanded by modern applications. More nodes, bigger packets, more security. All of these things increase the amount of data traffic in industrial networks. Traditional communication technologies like RS-485 or narrowband powerline communication struggle to meet the new requirements for industrial networks. Yet, for a lot of installations, it's not practical to install new wiring infrastructure like Ethernet. Even if it was practical, it still wouldn't meet all of today's requirements. Now, we're offering a new option, a high-speed powerline communication called HD-PLC that's developed specifically for the industrial IoT, including smart grids, smart buildings, smart lighting, and many others. Today, I'll be talking about the new requirements demanded by customers in the industrial IoT space and how we're addressing it with HD-PLC. Oops, sorry. So let me start off by a short background on how all this started. We were approached by several key customers in the industrial IoT space, and what they all told us was while they would like to stay with their existing communication protocols such as LonMark, BACnet, KNX, they were dissatisfied with the bandwidth limitations of the network itself. They felt it no longer supports the new requirements of IoT. Things like faster data rates, higher security, robustness. Also, they had other concerns such as availability, the solution's competitiveness, and cost of deployment. Additionally, they saw many of the industrial and building automation applications are converging. So they wanted a single network to handle all their communication needs, from running their most demanding video applications to simple controls. When we look at all these key system requirements, need for higher data rates, supporting more nodes, longer range communication, IP-based, high security, fast response times, and from an end application point of view, and when we are deciding which technology best fits today's requirements, the one technology that stands out is broadband power line communication. That's closest in meeting all the requirements of their end customers. HD-PLC is an OFDM-based broadband PLC technology developed to address the industrial and building automation markets, as well as many consumer applications. It's based on IEEE 1901 standard and ITU G.9905, and now being supported by LonMark as a new standard channel for LON. In the next few slides, I'll be giving you an overview of the technology and comparing it to some of the more popular communication technologies in use today, such as Ethernet and RS-485. If you've been in this space for a while, you already know that existing communication technologies require difficult trade-offs. With serial, such as RS-485, you get longer ranges, but have to sacrifice speed and are limited in the number of nodes you can deploy, among other installation complexities such as grounding issues, as well as cost of pulling new wiring. The low-speed wireless holds the promise of easier deployments, but range is an issue, has limited data rates, and latency is an issue with larger networks, and it can be easily jammed. Of course, low speed and narrowband PLC offers the lowest deployment cost, but with narrowband solutions, you're limited to kilobits speed, and it's not robust enough for a lot of the mission critical applications. And lastly, Ethernet. It's being tried by several companies. It addresses the speed, but its range is an issue, and cost of installing new Cat5 wiring keeps many of the projects from getting off the ground. LonMark International and other industry leaders, they recognize these challenges. That's why they have supported HD-PLC to become a new channel standard for high-speed wireline communication in both Standalec and ANSI. Finally, industrial designers have a communication technology that provides the bandwidth, range, and many other capabilities demanded by modern smart systems, all over the existing wiring structure, while using the same protocol stacks and tools that you're already familiar with and have used for many years, so reducing any learning curves. It's basically a hardware upgrade to your existing BAS. Our customers tell us that this is a real game changer, enabling smarter, more secure applications, faster and cheaper deployments, and plenty of performance for future application requirements. So here's what's so special about HD-PLC. For starters, it gives you a big performance upgrade from kilobits to megabits. So you can send bigger packets more often, reaching more nodes at faster speeds in large network configurations. You get the plug and play simplicity, free topology, and IP-based mesh networking, and works over any wires, AC, DC lines, coax, twisted pair, Ethernet. Today, it's typical to see multiple technologies used in buildings, from RS-485 to Ethernet to wireless and others. Wouldn't it be nice to have a single communication network to handle all your applications, from controlling a single actuator to running your most demanding application, such as your high-definition security camera, all using the same network throughout the building? Well, HD-PLC gives you that. And the biggest benefit is you get all of these capabilities without having to potentially add or replace any wires. Big performance advantages, lower deployment costs. It's a win-win for manufacturers, system integrators, and project owners. So let me tell you how this is possible. And let me back up and review some of the key characteristics between various wireline technologies in use today and how HD-PLC stacks up against them. Here, the x-axis shows the operating frequency for some of the more popular wireline communication technologies. And the y-axis shows the relative range to each other. I didn't put any numbers on the range as it varies depending on the line conditions, such as the type of cables, the type of devices on the line, number of branches, the noise on the line, and etc. We'll talk about that a little bit later in the next slides. So here, the lower frequency band, the longer your transmission. For example, RS-485 on this chart operates at the 9.6 kilohertz, having the longest range, whereas Ethernet operating at the 125 megahertz and above with the shortest range. So broadband PLC is in the middle, operating between 2 to 100 megahertz. There are a couple of unique features for HD-PLC. One, it's its frequency band, and the other is its repeating function. We selected the frequency band between 2 to 28 megahertz for optimum cost performance. We found the higher frequencies above 28 megahertz really doesn't add much more performance, while makes the chip architecture more complex and more expensive. The other unique feature is its repeating function. It extends the communication range comparable to those of low frequency technologies and performance of those of high frequency. With HD-PLC, you get the range of RS-485 and the performance of Ethernet and simplicity of wireless. Here I want to talk to you about some of the challenges of communicating over power lines and some history. For many years, companies shy away from PLC. And the reason is that narrowband PLC historically has been slow and unreliable. So it didn't get the adoption and left a negative impression in people's minds. Even so, today there are hundreds of millions of devices deployed using PLC. And that's because it is of its inherent advantages that we touched on earlier, and that's the ability to reuse the existing wiring. But as with any emerging technology, PLC has made great strides in solving many of the issues narrowband PLC faced in the past. So we are hopeful, and we want to encourage you to take another look at this new advanced OFDM-based broadband PLC for your upcoming products and projects. Power lines are a hostile environment for communication. The lower 10 kilohertz to 500 kilohertz frequency region is especially susceptible to interference, background noise, impulsive noise, and group delays. The figure shows the average noise in a typical power line channel. You can see the noise power distribution between 10 to 500 kilohertz is much stronger than signals above 2 megahertz, about 30 dB stronger. With broadband PLC, we have solved the inherent problems of narrowband PLC. First of all, we operate in the higher bands, where it's less noisy. And second, we operate over a wider bandwidth, which helps us apply more advanced communication techniques, such as using OFDM technology and applying more advanced forward error correction techniques to provide a more robust data communication and higher speeds in the presence of narrowband interferers, group delays, jammers, impulsive noise, and frequency selective attenuation. These techniques aren't new, and they've been used by many other technologies such as Wi-Fi, DSL, and others. So it's been proven to enhance the communication overall. We're just applying those techniques to power line communication now. One of the biggest innovations in HD-PLC is the use of a routing technique called CMSR, which stands for Centralized Matrix Source Routing. It is based on an ITU standard called G.9905. It was defined specifically for industrial networks where longer ranges, support for larger number of nodes, and robust communication is required. It allows any node to act as a repeater. With this technique, you can extend the range of broadband PLC by 10 times to several thousands of meters. Of course, range depends on many factors, so it's hard to be exact, but this can give you a good idea of its capabilities. We call this feature multi-hop. In addition, with this method, since the master handles all the transactions, we can drastically reduce the network traffic, allows having larger networks and very fast connections. Our customers are seeing authentication times of less than 30 seconds for large networks of 600 nodes from the time they turn on the system. The system continuously monitors the lines and dynamically selects the best route to transmit the information to its destination. This is what we call automatic routing with dynamic self-optimization and self-healing feature. For example, as you can see in the figure, if you want to transmit packets from the master to T3, the system continually monitors all the lines and looks at different characteristics like the phi rate, signal to noise, and the algorithm dynamically calculates the link cost every so often and determines which is the best route to terminal 3. And if the line conditions change, then it automatically changes the routing. We also added other features such as dual master capability, where if one master fails, the system automatically changes one of the terminals to act as a second master. Again, the whole goal is to provide the most robust communication throughout the network And I think we've achieved that with HD-PLC. The biggest advantage of HD-PLC is using the existing wiring infrastructure that's already in place. Whether it's power lines or other types of wiring, it gives you the ability to communicate through the same wires that provide power to the device. Or you can use the existing control lines that's already in place. Whether it's twisted pair coax Cat5, it works on all wires. The other advantage is the ability to bridge between various communication technologies or use it as an extender. In addition to enabling various bridging functions, you can also do power over Ethernet or power over coax. What it means is cutting one of the major expenses in any project, and that's not having to pull new wiring. And it is communication protocol independent. Whether it's LON, BACnet, KNX, or others, HD-PLC can transport it over any wires. Lastly, it is free topology. You can connect your network to any in any configuration, whether it's bus, star, mesh. HD-PLC supports it. So here are the key specs for HD-PLC. First of all, it's based on an internationally accepted IEEE 1901 standard. It uses many of the same schemes as Wi-Fi and other advanced high-speed communication technologies, such as wavelet OFDM, which allows a more efficient use of the frequency band, thereby allowing us to add more advanced forward error correction algorithms such as convolutional coding, resolving to achieve more robust transmission, faster speeds, lower latencies, higher security, as well as IP communication. Also, HD-PLC is supported by many internationally recognized organizations, including the HD-PLC Alliance and LonMark International. Interoperability and certification is done by the HD-PLC Alliance as well as LonMark International. We are now working with other members of BACnet and KNX to gain their support as well. So we are hoping to get more people involved in supporting these activities and see if we can make this technology the de facto standard for smart city applications. So to review, the technology we're presenting today meets all those requirements we talked about for today's smart city and more. HD-PLC addresses the higher data rates. The throughput is more than 90 megabits per second. Supports more nodes, up to 1024 nodes on a single network. Wider coverage, thousands of meters, and it's IP-based. It supports IPv6 and IPv4. It offers a strong encryption engine based on AES-128 for high security at every node, fast response times that are in milliseconds, and more than 200 messages per second. It's standards-based and available through multiple vendors. There is interoperability and certification process in place through both HD-PLC Alliance and LonMark International to ensure competitiveness and availability. And best of all, it offers the lowest deployment cost. So we believe we achieved all we were asked by our customers and the industry as a whole, and we met the challenge. We hope you now take advantage of it and use it in your next projects. These are some of the applications that take advantage of this technology. I can confidently say that the majority of the wired applications in use today use some sort of serial communication such as RS-485. There's also a number of installations that use narrowband PLC, and there are some newer systems that are now using Ethernet. As I pointed out, when comparing all these technologies, we can see none of them fully meet today's building automation requirements except HD-PLC. We believe that HD-PLC is a good option for the home and building automation as well as smart city applications such as smart street lighting, security and surveillance, emergency services, Wi-Fi hotspots, and many more. It provides the required data rates, security, coverage, and robustness that one would expect from their communication network. And lastly, here are the key takeaways from my section of the presentation. HD-PLC is a new high-speed wireline communications channel standard for smart cities. It offers higher data rates, more security, and has a wider coverage than many serial communications like RS-485, and gives you longer ranges, supports larger number of nodes, and lower cost than Ethernet. It works on any wire and offers free topology. It's protocol independent. Currently, we have ported LON, and we are working with BACnet and KNX members in the coming months to port those protocols as well. It is a great option for your retrofit projects where reusing the existing wiring infrastructure can save a lot of cost for your customers. And I hope you consider it for your next projects. This concludes my section of the presentation. I would just like to remind you to visit our webpage. There is a wealth of information there to help you make a better decision when it comes to your communication and networking needs. I would like to thank you again for your time and interest, and thanks again to LonMark International for arranging this webinar. I now would like to hand this over to Matthias from Gesitech. Thank you.
Yeah, okay, thank you. So I think I'm getting the screen now. In my presentation, I will talk about the basics. So how do we use HD-PLC for LON? You see here that I wrote CNP, which means Control Network Protocol. That's the magic terminology from the international standards like ANSI CTA 709 or in ISO IEC the 4908. In a standard you cannot write LON, but so in that case it is the Control Network Protocol. So I will talk about the basics. I will talk about how to create devices, what is already available, and at the end I will talk a little bit about use cases and existing projects. I'm mapping here down the performance, especially to what performance we can have on an HD-PLC. We distinguish between an HD-PLC system without hopping, what you may find more in a smart home, and in a multi-hopping environment with large networks, which is a building or street lighting. So you see that we have in the multi-hopping environment a throughput of 10 megabits per second, which is pretty fast. LON physical channel. The latency is a little bit higher than you know in a hopping system, which is 220 milliseconds. By the way, we did a lot of performance tuning and testing with all the companies contributing in creating that channel in the last 15 or even 18 months to tweak, to find all the screws we can have for, what's that? Okay, that was my PC. tweak everything what we can do. In total, with a hopping environment, we have a message throughput which is more than 200 milliseconds. That's pretty high. Packet loss on the power line system, Michael already mentioned all the pitfalls you can have, is less than 2%. And keep in mind, we all the time have AES encryption in all messages. So it is, I think it is the most secure channel we actually have. We can have a whitelisting of devices so that access to the HD-PLC channel is limited by a list of media MAC addresses. And additionally, please keep in mind, it is on any cable, even if it is power line communication called. It can be a twisted pair, and we know that it can run in parallel with a Modbus, with a CAN, and even with a TP-FT10 LON channel simultaneously. What are we doing for LON in HD-PLC? We are packing LON messages in UDP frames. So HD-PLC is like an Ethernet cable, like a virtual Ethernet cable. So we are using, of course, UDP. People being familiar with IP 852, they know that there's a nightmare of the channel master, which is setting up the communication between the different 852 devices. We don't need that anymore. In our last tests, we figured out that we don't even need an IP address setup. That makes the setup and the installation of a CNP-HD-PLC system easy. There is a special role in the system. We need to have a master functionality for the LON HD-PLC, additionally to the HD-PLC master function, who is calculating the least cost routing. Oops. Sorry, my PC is actually it is doing funny things, so I lost a little short. Windows 10 ran an update in the background. It's new for me. We are working with packet aggregation and different timeouts. And please keep in mind that all of that LON is simultaneously running with all other IP applications at the same time. So like audio, video, other automation protocols, everything is running in parallel at the same time. And my benchmark here in the company is normally using full HD video camera running on HD-PLC, or using other protocols, making high bandwidth with high path. Each device in an HD-PLC network is a protocol analyzer. So, you know, even people who have been familiar with narrowband power line in the past, they say they had a big box which has been measuring the network. Each device in HD-PLC is a protocol analyzer, calculating the performance, showing the signal platform, allowed to do some settings, have a view as a topology update, or do a firmware update in devices. So each device is able to do that. The silicon is coming from Panasonic and from MegaChips. EasyTech is dealing with MegaChips. Other companies are using Panasonic. I'll show that later. But keep in mind, it is quite simple to maintain a network and to find out what's going on. So what do we need to do to make own hardware or to create a LON HD-PLC device? At first, you need to have a line coupling unit. So you see that on the left side. That's pretty simple, and it's pretty cheap. You see it's just a single coil with 2 pieces of wire, and that's all. That makes it very simple compared with narrowband technologies. We need to have, of course, an HD-PLC CPU, which is running the HD-PLC software stack. And we need to have an application CPU, which is running your application and driving the inputs and outputs. Here I have seen place cheap Cortex M0 CPU from ST. This is what we use. You can use a neuron chip additionally to keep your existing neuron know-how and just port your existing neuron applications into the HD-PLC world. What's normally a little bit underestimated is for power line devices, you need to have a very good power supply with low noise. The link budget is something between 80 or 90 dB. And you've seen that we have a bandwidth from 2 to 28 megahertz. So all of your schematics, and especially the power supply, should keep out of that frequency range. Otherwise, you will sacrifice the performance. You can add the Ethernet with a PHY. You can add a serial port for RS-232 or RS-485, and then that's your device. We have two solutions available. The first one is from Gizitech and MegaChips. We have the LON protocol stack integrated directly into the HD-PLC CPU. So we made the HD-PLC chip from MegaChips to be the LON chip on HD-PLC. We are driving an end user's application on serial attached STM32 CPU from ST. Can be any other CPU you can imagine. We had been asked for 8051 based designs. It can be, for instance, microchip or something like that. And we are selling that as a reference design. In that case, if you do it in that way, you are programming in an ANSI C environment, which is slightly different from what the LON developers know from Neuron C. The alternative solution you see on the right side from Foster Schwabe and Panasonic, they have built an HD-PLC transceiver for a Neuron 6000. So, you know, a Neuron chip can drive different transceivers like the TP-FD10 or an RS-485 or other physical layers. So they made a transceiver which can be easily adapted by the 5 communication ports to a Neuron chip, and then you have a very simple solution to make it together with a LON chip, and you can still use your existing know-how in Neuron C, or you can even upgrade your applications to use the new physical channel. We are selling together with MegaChips an evaluation kit, which comes with 2 HD-PLC boxes. You see that here, together with all the power cables you need all over the world, breakout boards. We have an HD-PLC master. We put the ST-Link debugger into the box. We have some licensed software you get. Additionally, you get the source code, all the software tools you need, and that enables you to build your HD-PLC LON devices, or if we add another protocol stack, you can do that for a different protocol. And furthermore, you can use other cablings like power cabling. We mentioned already twisted pair cabling, and you can use the kit for other types of wires too. For that evaluation kit, because it is different from the standard Neuron C development, I'm showing here the workflow. If you are working with Neuron C, you are most likely familiar with the node builder utility, which is doing all the magic stuff like creating the LON network interface description. We added a known tool, which is creating that external interface file, the XIF, and derives an ANSI C framework for your application, which includes all the definitions for network variables, functional blocks, and adding callback events, which are triggered when there is an update from the network. So you just have to drop in your application specific I/O, handling the inputs and outputs, updating network variables, and handling the callback events. So a typical application is just maybe 20, 30, 40 lines of code to generate a simple switch or lamp actuator. So that's all what you need to do. You can do that in a few minutes. By the way, we made a comparison with BACnet, and it took us 2 days to make the correct configuration. So it's much simpler. You find devices already. That's our first HD-PLC device. We made a simple HD-PLC Ethernet bridge, including RS485, which can be mounted on the DIN rail bridge. It is dedicated to be used at first generically for Ethernet on HD-PLC, for RS485, for instance, with Modbus on HD-PLC. It acts additionally as LON HD-PLC master. We use it as an interface for our LON router. We are working with Echelon to get that as an interface for the ILON 700 to make that the HD-PLC interface for that device. And you can use it for any application. You have seen in the evaluation kit, we are having drivers for the PC and for Linux to become a LON HD-PLC virtual device. And of course, this needs a physical interface. And that's a magic brick you need for all of that. That's our router. EasyTech is selling routers for LON since more or less a decade. And we make our standard LON IP router to be an HD-PLC router just by adding that generic HD-PLC Ethernet bridge. Maybe some people have seen that already working on the AHR Expo in Atlanta, or maybe on some of the demos which had been showcased in the US in the last months. A real application device comes from the other company working with that, from Vossloh-Schwabe, being a Panasonic subsidiary. They created with the IPC HD-PLC the first auto luminaire controller for HD-PLC. It can drive any type of street lighting ballast with pulse width modulation, DALI, or 0 to 10 volts. It can drive any LED street lighting ballast. And you see here, and keep that in mind for the next slides, you can see there is an Ethernet cable coming out of that. So it is not only a street lighting ballast, it is additionally something which gives you high-speed Ethernet into any streetlight pole, or indoor when you use it for large halls, like in an airport, to drive LED lighting. So that's existent, and it is used in real projects. So where do we find use cases for HD-PLC? You find it everywhere where you need to have high performance Ethernet with low latency at the edge. So if you see other outdoor wide area wireless networks, you know that they are pretty slow, having a high latency. And just imagine you want to turn on this complete street with its lighting, and you will be waiting that the lamps will turn on simultaneously. With any wireless topology, you will see something like flash lighting, but not simultaneously. So you will have it in lighting insecurity. Infotainment can be done in parallel. Imagine just a TFT screen at a streetlight pole. You can control charging of e-vehicles. You can collect weather data, or you can do traffic control, which is a great issue here in Germany regarding the diesel cars. Okay, emergency safety, it is maybe CCTV, therefore you need the Ethernet. It can be audio, it can be a push button like an SOS. We can do traffic control, and an interesting one is microclimate changes. You see the hailstorm on top of the car there, so you want to put it maybe into the garage when you see that there's a hailstorm approaching. Weather becomes worse. We know that due to the climate change, and we have a very high number of local microclimate effects here in Germany, and I'm pretty sure you have the same issue in the US and all over the world. Let's go to the most simple use case. You see there's a street lighting pole and there's a Wi-Fi access point. It is close to the shore of a very touristic region at the Baltic Sea in Germany. The name is Usedom of that town. At the shore, we have very bad 4G connectivity. And unfortunately, in Europe, Germany has a ranking for the 4G connectivity behind Albania, which is a very poor country at all. So to make that shore region attractive for tourists, the mayor of Usedom decided we need to improve the Wi-Fi at the shore, and they had been using the street lighting as a backbone to put Wi-Fi access points at the streetlight poles. And that's a more or less generic use of HD-PLC, but we have that magic HD-PLC streetlight controllers inside. So you're using the power line for the controls, which is implemented in LON, and you are carrying very simple internet access at the same time on the same wire. The next is in the city of Solingen. Maybe you know Solingen as the city where the sharp knives come from. Here again, it is a Vossloh-Schwabe project. There are SOS buttons at the streetlight pole, just to give the inhabitants of Solingen a better feeling of security and safety. There's an audio system, there's CCTV. So if somebody is pushing the SOS button, the audio system and the CCTV is turned on. They are collecting weather information. Solingen is a very still region, so if there is a strong rain, the lower regions of Solingen can be flooded, and the fire brigade in Solingen is very interested in getting that information in short terms to protect the lower regions. We have again air pollution sensors, which can be used in the next step of the project to implement dynamic traffic guidance. Okay, so we have seen some use cases in existing projects. So it's not from the scratch, it's not from the lab what we had been presenting here in that webinar. It's real. You can have products, and the products are in the first projects running. Okay, I handle over back to Ron.
Thank you, Matthias, and I want to thank all of our speakers today. We're going to open up for questions. So I know some of you have already started putting questions in the question box. We'll get to those in just a minute. Shannon, you want to handle the logistics here on this slide, please?
Sure. Just as a reminder, the recording and the slides will be available on the LonMark website within about 5 working days. So there will be an email sent out from GoToWebinar alerting folks when these slides are available. And then we just want you to be aware that there will be future webinars continuing throughout the year. Some of those topics to include interoperability and integration of open systems, ISM, RF, an introduction to web services, and IoT and edge servers. So be on the lookout for more information on timing of when those webinars will be presented. And with that, I'll turn it back to you, Ron, for Q&A.
Yeah, and again, if you have questions, put them into the chat box here. I know we're coming up on our hour, so we want to thank you. For those who are going to stay, we'll get through all the questions. But for those who are going to leave, thank you for attending today. And as Shannon said, we'll have both the slide deck and the audio and video posted. Give us about 4 or 5 days, and we'll get to that. So let's start off with some of the questions here. The first one I'm going to address to Michael. Michael, can you talk a little bit about the HD-PLC IEEE standard and sort of the definition of what IEEE is doing and how LonMark is putting the application layer and the higher layers on top. So what's ongoing with IEEE?
Okay, so HD-PLC actually became standard many years ago, about 7 years ago, and we've continually improved it. So originally the technology was developed for home networking applications, and we started the ITU G.9905 to gear it towards industrial applications. And just most recently, about maybe 3 months ago, I think it was March, we have a new updated standard, and we are developing a chip based on the new standard, which adds a lot of new capabilities, including higher speeds up to 1 gigabit per second. So the chip, we are shooting to have samples next year. So we're actively working on improving the technology. So, you know, this is, we're looking at it as a very long-term technology for industrial use. Did I answer the question?
Yeah, that's great. I think that actually leads into the next question, which is, you mentioned that the IEEE standard was really initially a home application-based. So the question is, does HD-PLC play nicely and interoperate with home plug AV and or GHN?
Good question. So as part of the IEEE 1901, we have what's called ISP, Inter-System Protocol, which allows the different PLC technologies to interoperate. They're not interoperable, but they can interoperate. So it's a CDMA type of a system. And so we've solved that problem as long as the other power line technologies support the ISP. There should be no problems.
So in that case, just to extrapolate a little bit, so let's say you had a facility, a building or home that had the HD-PLC running LON, and you also had another application running IEEE HD-PLC running some other protocol in the same environment, but all running on the same power line. Could those potentially, using that ISP, interoperate or at least coexist without interfering with each other? Is that what?
Yeah, definitely they can coexist, and as long as it is HD-PLC to HD-PLC, it doesn't matter if it's running LON or BACnet or any other protocol.
Okay, well, that's great.
So you could mix them.
So that's sort of the next question, which is relating to the use of broadband PLC in China. Will the HD-PLC interoperate with systems designated or designed for the Chinese market? I'm not sure if you can answer that, but it seems as though there's an opportunity there for interoperability or at least communication on the same network, but maybe not full interoperability. Are you familiar with what the Chinese market is doing?
Sure. They do have, there is a technology developed by Huawei, I think, and they actually work up to 12 megahertz. So our technology is 2 to 28 megahertz. Theirs is 2 to 12 megahertz. As long as, again, they support ISP, there is no problem. And then what we could do is set our start frequency from 12 megahertz and up, so they don't interfere. Of course, you may lose, well, you do lose bandwidth and some speed, but it is doable. So I'm not very familiar with the details if they support ISP or not. they are standardizing it in IEEE as well. It's a 1901, a version of 1901. So I do think that they will support ISP.
Okay, all right, great. Well, at least there's an opportunity there for coexistence and maybe even a level of interoperability. Next question that comes up, again, I think this is for you, or maybe Matthias, is on the bridges. So will the LON HD-PLC bridge be disrupted by common Ethernet range extenders? I think what you're talking about, the question there is in a typical, 110 or 220 environment with these range extenders that are using PLC for that. What's the interference there? Do either of you know the answer to that?
Maybe Matthias is better positioned to answer it. I don't know what technology they're using to extend the Ethernet. If it's power line communication, then again, ISP comes into play. So I really don't know the answer to that.
Matthias, any knowledge on that?
For me, it's similar, but from my perspective, most of the Ethernet extenders over power line are using some variants of IEEE 1901, so they may use zone plug or something else. So they should have ISP inside, and then in that case, there is no interference.
So I think the answer to the question is it sort of depends upon what technology the range extender is using. And it makes a very good case for if you are going to be using HD-PLC and you're going to use these range extenders to make sure they are ISP enabled. So that's sort of a specification thing.
So Ron, I do know that some of the earlier versions of HomePlug did not support ISP, which really means that they're not compliant with the standard.
Right, right.
So to be compliant with the standard, with the IEEE 1901, you must have ISP implemented. And if they don't, that means they're not compliant.
Yeah, so I think coming back to the question, it will not only depend upon the environment and what hardware you're using, but what level of compliance the other devices are going to be using. So, all right, so let's move on to the next one. There's another one about connectivity. Does the phasing of the wire still matter in HD-PLC? Is it installed on all three phases? I think we're talking about in a typical home with a three-phase connection. This is, in the U.S. market specifically, the coupling circuits and how do the coupling circuits work? So maybe Matthias, you can handle that one.
Yeah, I can handle that one. So normally an HD-PLC device is a single-phase device. So if you are using a three-phase environment, of course you start thinking you are having an issue. What we normally have in our test environments is we try to get rid of crosstalk between the different phases. So I imagine, in the normal house, you will have enough crosstalk between the phases that it works. If it does not work, you can use any off-the-shelf home plug phase coupler, because both systems are working in the same bandwidth, in the same frequency range. Phase couplers are normally simple capacitive couplers between the two wires.
So in a typical home environment, you might need to put in a coupler across the phases. In a commercial environment or in the outdoor lighting, there's another question that relates to this: is how do you bridge a transformer? Same sort of thing as using a coupling circuit designed specifically for that environment. Is that accurate?
Yeah, that's accurate.
Okay.
Ron, also in the three-phase case, we use a neutral line to transmit the data. So it's common through the phases. So that's another way to solve that problem.
Right, exactly. Okay. Let's see. So let's go on to the next question. So this one is about smart metering. So is there an ecosystem for smart metering? I'm not sure we're there yet. It's a very new technology, especially in the LON market, but maybe there's something within the IEEE. So, Michael, is there a smart metering effort that you're aware of?
Oh, absolutely, absolutely. Actually, if you go to our webpage, there is a white paper, there is a case study on some of the work we are doing in smart grid and for meter reading. And actually, we have several projects ongoing in Europe and in Asia. So Nuri Telecom, as an example, has systems based on it. Panasonic has meters based on it. So we're pretty active. We had a press release with Panasonic and Tai Power in Taiwan, where they've decided to use HD-PLC for a smart grid. So that's within the last 6 months that they decided. Yes. So yeah, there is a press release and a case study on our webpage you can read up on.
So for those who are maybe new to LonMark has a long history in the smart metering market, with lots of, millions of LonWorks devices being used in various smart metering applications. So this could open up some new opportunities there.
Right.
Even some of the existing sites may be able to upgrade. There's a case study of the utility in Italy that has something like 27 or close to 30 million installed PLC LON devices, but this is the older technology, the narrowband. So absolutely, this could be an application to improve that.
Ron, they're finding that the older, the legacy power line communication technologies like the narrowband and G3 and Prime, they don't have enough bandwidth to handle the security requirements. As an example, in Germany, I know that they couldn't qualify those technologies purely due to security concerns. Now, with HD-PLC and broadband technology, you have the bandwidth to add all the additional security. This is above the AES 128.
Yeah, so great opportunities there in the existing smart metering market. So that's great. All right, let's move on to the next question. So this is regarding development kits. What's the current availability of HD-PLC blue chip module or a breakout board, and concerning volume, end of life expected, price range? I'm not sure you can answer that. Maybe Matthias, one of the two of you can answer that one. What do you think?
Sure, I can do it. We have EV kits and development kits available now. Actually, the lead times are very short. So yes, you can order that through our webpage if you like, or for the LON version, you can go through Gesitech, or you can contact us. So it is available, and we've been shipping these chips for many years. So it's in volume production.
Yep. For us, it is the same. We have EVKs on stock.
Yeah, this is from Felix. Felix, if you're still there, I'm not sure I understand what you were talking about of the end of life expected. So maybe you could extend that. I know you're still online. Let's move on. I think there was a couple of other just general comments on the questions earlier. There was one about common range extenders don't support ISP. Yeah, I would expect that, Roland, and it could be a problem, but again, testing in the environment is always important for any type of common communication using power line. And then the last question we currently have, let me just read it here. I think we covered this already, but I interpreted another question from David having to do with bridging transformers. One of the questions I had, which is along those lines, let's say you have a building and the building has existing twisted pair wiring, and it could very well be something like telephone wiring. This goes back, a couple of decades, and you've got old 24 gauge wire, and you have an opportunity to, instead of, in very difficult situations, run new wire. Can you use the HDPLC over a old 2-wire telephone wire to communicate to field sensors or across different locations within a building that's the only wire path you have available?
Maybe you can think of it this way. We use the copper as a medium to transmit the data. So it doesn't matter what kind of cable it is. Yes, you can use it on phone lines as well.
Yeah, that's come up in some case applications with, especially in historical buildings where there may be wires put in from 1920s or 30s, and running new wire is just not as feasible these days as to try and preserve the environment. So this is an application where you could use those old wires. As long as you have connectivity, you should be able to communicate, especially if they're not.
Correct. Yeah, just think of it as a pipeline,
Okay. All right. That's the end of our questions. Just as a summary, thank you all for attending. I want to thank our speakers today from LonMark, Esitec, and MegaChips. And again, the slides and the recording will be posted as soon as we post-process here. Stay tuned for more information about our upcoming webinars. We'll have one very soon on the wireless RF transceiver that is in parallel development that we've mentioned. And if you would like more information, please visit our website, lonmark.org, or send an email to info@lonmark.org if you have any other questions, and we'll put you in touch with the speakers as needed. And again, I want to thank all of our speakers. Just so you know, Ernst is in Austria, and Matthias is in Germany, and Michael is in California, and Shannon is in Arizona, and I'm in California. So we are a worldwide webinar today, and we have had members from really around the globe online today. I've looked at where the people are from. So again, thank you, and we appreciate your taking the time today. Shannon, any last housekeeping issues?
No, just be sure to follow us on Twitter, LinkedIn, and we'll be sharing more information about the upcoming webinars that were referenced earlier. And thank you again to our speakers and to everyone who listened in today.
Thank you all. Have a good day.
Thank you.
Bye.
Bye-bye.
Bye-bye.